There's one more thing I want to tell you about when we're working with objects. So let's go back to, we'll assume we have a variable of type porcupine. And remember, when I declare that variable, it doesn't mean I've created a porcupine object. All it means is that the quilly variable could refer to a porcupine object one day. And so the question is, what kind of thing am I allowed to store in this variable? What could I store in quilly? I think we'll write it like this. So what could we put there? Well, we could put any expression that evaluates to be a porcupine object, such as we could write, let's go back in time for a moment, we could write new porcupine and create a porcupine object. We can call a method, blah, 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 that's a method call that returns a porcupine. But there's one other value that we can store in here. So what can we store in quilly? Well, we can store the memory address of a porcupine object, right? Or a reference to a porcupine object. Those are really equivalent porcupine object, equivalent ways of thinking about it. But there's one other thing I can store in it, and that is the null value. So null is a keyword in Java. And the meaning of null is that it's sort of the absence of a memory address. Null is the absence of an object. The null is the absence of a memory address, however we want to think about it. So, in other words, in this variable I can store a memory address, which is the location of a porcupine object, or I can store null, which means I don't have a porcupine object, right? So that code would look something like quilly gets the value of null. And null would light up in whatever development environment you're using, because null is a keyword. And then later on, if I wanted, I could write code like if quilly is null, then do something, right? I can test if something is null, if my variable stores null. And you may wonder, why on earth would I want to do that? But maybe I have this variable and I don't have a porcupine to put in it yet. Or maybe I want to keep track of the fact, like maybe I'm keeping track of my pet porcupine, and right now I don't have a pet porcupine, but at some point later maybe I will get porcupine from the pet store, right? But I haven't been to the pet store yet, so at this moment I want to store null, indicating I haven't gotten a porcupine yet. Maybe it'll be 10 years before I can finally save up enough money to buy a porcupine. I don't know. Alright, that's a goofy example, but you'll see the null value many times. The more you program, the more null you'll see. I want to get into what can go wrong with null, because for a long time most people's experience with null is all of the bad things that happen when you work with null. So suppose, again, remember that I had a class. Do I have that class definition handy? Let me show you. There's my porcupine class. It's got a number of quills and whether or not my porcupine is angry. So we could write quilly.numQuills, and that should tell me how many quills are in it, right? So we could say quilly should have 10,000 quills. Actually, let's work through a complete example. So I'm going to make my porcupine variable. I'm going to make quilly refer to a new porcupine object, and in it I will store the number 10,000, which is the number of quills my porcupine has. If I now say I would like to print the value of numQuills, it's going to print 10,000. Now what goes wrong if instead of working with 10,000 I find myself, or instead of working with a porcupine object like this one, what goes wrong if I instead had null? What if I didn't have a porcupine yet? So quilly, and instead we wrote this, and then at some point later we said I would like you to print out the value of quilly numQuills. What's going to happen? And this may have already happened to you, which is maybe why you're turning to this video. I don't know. What's going to happen is I'm going to get something called a null pointer exception in Java. And what does a null pointer exception mean? It simply means you don't have an object. Quilly is not actually a porcupine. Quilly is null. it's the absence of a porcupine. You don't have an object. And so when you ask that null dot num quills, you ask null how many quills it has. Well, null isn't the memory address of a porcupine, therefore it doesn't correspond to something where you can ask how many quills it has, and Java lets you know that by crashing with a null pointer exception. So we don't actually have an object. Whenever you see null pointer exception, it means you don't really have an object. You have null, and you're trying to use it as if you had an object, as if you really had an object. What do you do when you get a null pointer exception? And actually, I should point out there's many other things where you'll see a null pointer exception. So let me, if you just work through very quickly some examples. Anytime if I have an object and I access a field, actually, let me write it this way. If I have null and I access a field, that's going to crash with a null pointer exception. It's also going to crash if I have null and I call a method on it, because although you haven't seen it if you're watching my videos in order, you'll eventually see that we can call methods on objects, like for example, give me the length of a string, and if instead of having a string I have null and I ask it for its length, that's also going to crash with a null pointer exception. And finally, if you know what an array is, if I have an array and I decide to access some index of my array, or maybe I want the length of my array, something like that, and I don't really have an array, I have null, that will also crash. So any of these things will result in a null pointer exception. And that means when you see a null pointer exception, how do you fix it? First, you look for a dot. Actually, let's see. Look to the left of a dot or an open bracket, right? Because if we look at here, anywhere we have a dot or an open bracket, the thing to the left might be null. So look to left. So, and whatever is to the left, I guess there's really only one rule, whatever is to the left is null. So that, in other words, you get a line of code where you get your error message, right? So maybe it says null pointer exception at line 78. You look on line 78 and you find, so let's say null pointer on line 78. You go to look at line 78, and what you find there is a line of code that says if q.numQuills equals 10,000, then, you know, something like that. And what does that, and hopefully that's the only thing on that line. So what does that mean? That means you look for a dot or an open bracket if you know about arrays, a dot if you know about objects, and whatever's to the left of that dot must have been null. And in this case, what's to the left of the dot is q, so q must be null. Now you have the hard problem of figuring out, why is q null? Should q have been null? If q could have been null, then maybe the fix is to test if q is not null before I start asking q for its number of quills. But maybe q should not be null, right? Maybe there's a problem in my program, and now I need to back up and figure out how q ended up being null. Sometimes, in fact many times, the reason you'll get a null pointer exception is because let's write this, the default value of a reference type field is null. So if we define a class, public class, I don't want to define a real name for a class, there we go, Felqua, and in that class we have some sort of field, field1, and field1 refers to a porcupine or a point or some reference type, maybe a string, right? Some reference type such as porcupine. If I never initialize that field, then that field will store the value null. If I then later say, you know, x is a Felqua, and I don't initialize the field, and so now I say I start using field1, that's going to give me a null pointer exception. So when I see a null pointer exception at this line, I look at the dot, I look to the left of the dot. Oh, wait, no, sorry, that's not what I meant. X.field1 is fine. I'm actually allowed to get back the value null. In fact, I think that's probably worth summarizing, but we'll get to that in a second. If I say x.field1, I get back the value null. If I now ask that for its number of quills, because it's a porcupine, that's going to crash. Right? That's going to crash. So this line here gets me one of those null pointer exceptions. And when I see a null pointer exception, I look for the dot on the line, and uh-oh, there's two things to the left of a dot. There's x, and there's x dot field 1, which is what's to the left of this dot. So now I have to worry about, well, was x null or was x dot field 1 null? From this code, I can tell, ooh, I know x wasn't null, so it must have been x dot field 1. But sometimes I'm going to have to think very carefully about what was null. All right, I want to get to what things don't give you a null pointer exception. I think that might be helpful, because you might start to think anytime you use a null, you get back a null pointer exception, and that's not true. So here are some things you can do with null. You can pass null to a method. Right, so there's nothing wrong with me writing f of null. That's perfectly fine. That's not going to crash. Unless inside of f I do something I shouldn't with that null. So what else can I do? You can return null from a method. Right, so there's nothing wrong with me calling a method that gives me back the value null. That's perfectly fine too. The only thing I can't do is I can't use null like an object. You cannot use null as if it was an object or an array, and specifically, you cannot access a field of null, call a method of null, or access an index of null. In other words, you can't do all of these things that we just saw up here. You can't do null dot, and you can't do null bracket. You can pass null, you can get null back, but you can't start treating null like a full object and then asking it to do things for you, like get the x-coordinate or ask for its number of quills or something. That's what's going to get you in trouble. So I hope that gives you some sense of what a null pointer exception is and how to deal with it when they occur. I probably haven't convinced you that null is actually a useful value, but that's okay. The more programming you do, the more you'll see that null is actually a very useful idea. Anytime I want to store something that to indicate that I don't have an object, where I deliberately don't have an object at the moment.